Hi, this is Joe from EfiWires, and the purpose of this video is to give you an overview of the Harness Design Studio. I'm going to explain how it works, how to use it, and some of the concepts that it uses behind the scenes so you have a better understanding of what it's doing and how to use it effectively and get going quickly. So give me 10 to 15 minutes of your time and you should be good to jump in and try it out for yourself. When you first log into the Design Studio, you'll be taken to the dashboard, which gives you a snapshot of the entire system and any projects that you have in it. As of late April 2026, this is a new software product and it's in beta release right now, so you may have a bumpy road as you use it. There may be bugs, there may be incomplete features. There may not be the data that you want to use in the system yet. So I am looking for feedback on all of those things, the good, the bad, what's missing. Any sort of feedback will be very helpful to make sure that this product heads in the direction that the users want it to. You can provide that feedback by sending an email to support@efiwires.com. The Harness Design Studio is not run on a subscription model, so there will be no recurring subscription to use it. Rather, it's run on a project model, which means you will have to purchase a project. It'll be a one-time fee. The beta pricing for a project is $99.99. So basically for $100, one-time fee, you get access to that project for life. Now that said, as a new user, you will be given a free starter project, which is a fully featured project, which is where we're going to run the demo here in a minute. But you will have access to that for free. You can use it as a playground to learn how to use the studio, then you can also reset that project back to a blank state, and then you can use it for an actual real project however you want with no limitations. But if you need a second and third and fourth projects, then you will be purchasing those each for a one-time payment. The concept is that a project is probably going to be a vehicle that you're wiring, although it could also be maybe a production harness that you're going to sell a bunch of. You just pay for the project one time to design that harness, and then you own it for life. All right, let's get into how the Design Studio works. It's a data-driven application, not a drawing tool. So what I mean by data-driven is there are libraries of components, and all of these components have pinouts defined in the database. There are also rule sets, which are called profiles, that apply rules as components are added to the project for how to wire them together, like what kind of wire to use, what color, what size, based on circuit and that sort of thing. So with all that data built into the libraries and the rules, the system can do most of the work for you when you're building a harness. So let's take a closer look at some of these items. We'll come to the libraries, devices, control modules list, and you can see there are a few control modules in the library at this point. We're going to look at the Holley HP ECU. If we click on that, you can see some basic information about the Holley HP. And if we click into the connections, we can see that the three main connections, the power connector and then the J1 and J1A and J1B connectors, are defined with their part numbers and everything. And if we were to click into one of these, we can see the pinouts for each of the connectors. So we can see that the J1A connector has these circuits defined, and the ones with auto create terminal checked will automatically have terminals and wires added as soon as you drop that Holley HP into a project. If you're looking for control modules or any other devices that you need to use that are not currently in the system, you can create your own by clicking the Create Control Module, or you can copy an existing system library one and then edit it as you need. This is one of the main points where I need feedback from beta users is what control modules do you want to see in the system so that you don't have to create them yourself. Now let's get into the profiles. Like I mentioned earlier, the profiles are rule sets that determine how the wires are going to be chosen and wired together, not just the wires, but other things as well. So there's only 3 in the system at this point in time. There's one for the Holley EFI, which I'm going to look at because I'm using the Holley HP as the demo. So for each profile, you can set up rules for which terminals, splices, and wires are going to be chosen automatically, or at least attempted to be chosen automatically by the system. Each one of these has a default set, so if you don't put any other rules in here, the system, if you use the Holley EFI profile in your project, the system is going to prefer using solid crimp, non-insulated, tin-plated terminals. If that particular combination doesn't exist for a given connector type, it'll choose something else, but this is going to be the preference. And the same goes for splices. The system default is solid, non-insulated parallel splice with tin plating. It gets more interesting when we get to the wires because now we have all of the circuit functions defined. The default wire is going to be a white 20 gauge TXL wire that's 120 inches long. But if the circuit that a particular wire is being assigned to is any of these circuits that are defined in here, then the values on the row that pertain to that circuit will override the system defaults. So let's just, like, for example, if we look at the coil 1 signal, it's going to use a yellow wire with a white stripe instead of a white wire. But it does not have anything else defined in here, so it's still going to default to 120 inches, 20 gauge TXL. Whereas if we look at the battery negative wire, it's going to use a black wire. It's going to be only 36 inches long, and it's going to use a 2 gauge cable of the TPE type, which is the motorsport cable. So when we get into building the harness, you'll see that these wire colors and sizes are going to be automatically chosen by the system as we go. All right, let's start building a harness. If we go to the projects tab, we can see the list of projects. It's another place you can buy a new project if you need to. And then the most recent project will always be here, and then the older ones will continue this way. I'm going to build this in the empty project here, so you'll have the starter project that you can build in, but I'm going to go ahead and use this and start from scratch. So I'm just going to give it a quick name and make sure that you have a profile selected. This is a required field. I'm going to use the Holley EFI. The rest of the fields in here are optional, so I'm just going to skip them for right now. But then I'm going to move on to the next tab for the devices. I'm going to start adding devices to the project. And generally you'll want to start with the devices that have the most circuits on them. So usually the ECU. So I'm going to come to the control modules, which is where the ECUs live, and I'm going to find the Holley HP ECU and click it. And when I click that, you'll see it'll start spinning, and what's going on in the background right now is it's adding that ECU to the project, but it's also creating all those wires that I showed you earlier, including their connectors and their terminations. So if we come up here and look at the other tabs across the top, we can see that we now have the J1A and J1B connectors along with the power connector. There's no boots or back shells right now, but the terminals were added for those connectors, their part numbers and everything. It has not created any splices yet. It created the wires that were set to auto create, and you'll see that right now they all terminate from, based on their circuit, they all terminate from the right connector port, but they all have loose ends on the other end at this point. So let's go back to devices and add some more stuff, and we'll see how they get wired up. Let's do some fuel injectors next. There's a shortcut over here on the fuel injectors where you can add multiple in one click. So let's just pick an EV6 generic injector and tell it I want 8 of them, and it'll start building all 8 injectors in the background and numbering them appropriately. So when this is done, we'll have fuel injectors 1 through 8. And if we go back to the wires and we look at the fuel injectors, we'll see that they have been wired up. Come back to devices here. Let's do some ignition coils. And again, I can add coils one by one here, but I want to just use the shortcut. I'll choose the LS3 coil. I'll do 8 of those. And again, it'll create them in the background. It takes a little bit longer for the coils because there's more wires to build. So the more connection points, the longer these things take. But they're all pretty quick. So you just wait for those to finish. And when they're done, we can move on to the next step. Since I'm just doing a quick demo here, let's skip down to throttle devices and just assume we're building a cable throttle powered car. So we'll add a throttle position sensor, and we'll add idle air control valve. And then let's go to sensors, and we'll just add a couple. When you bring up the sensor list, you can filter by type. Like I want to look at the wideband sensors. Let's add an NTK. And then let's do one more. Let's do an air temperature sensor. And I'll use one of these Rife generic air temperature sensors. It's not specific to a certain circuit type, but I'll choose this one. I'll show you what I'm talking about here. It comes in with just the generic label of temp, but I'm going to use this as the intake air temp. So I want to give it an IAT label, and then I'll come into the connections, and you'll see that the sensor ground was automatically wired, but the temp signal didn't know where to go because this was a generic sensor. So I will assign the circuit here, and I can search for the air temp circuit. I'll select the intake air temp, and then once the circuit's assigned, I can click here on the wire, and I can step through this wizard that knows that because it was the manifold intake temp, that it should use a blue wire because that's what's defined in the Holley profile. So I do that, and then it wires up a blue wire to the J1A pin 11. And now if we come up and look at the wires, we can see that most of them have terminations on both ends. And if we use this has loose end filter, we can quickly look and see which wires in the project have a loose end and haven't been wired on both ends. So we could then go back and make sure we add the rest of these sensors so that the wires are connected on both ends. Now let's look at the splices that were created during this process. You'll see there are splices for the fuel injector power, the coil signal ground, the cylinder head ground, the coil power, and the sensor ground. And you'll notice that they're all, or many of them are different sizes. That's because the system automatically sizes the splices based on the bundle of wires that are in them. So if we look at sensor ground, for example, we can look at a schematic here, and we can see that right now it's got the throttle position sensor and the intake air temp sensor ground going through splice 5 and being fed by the J1A pin 18. And it chose a splice that will work with the 3 20 gauge wires. If you want to change to a different splice, you can do that. But also, if we add more sensors, and as more wires are added to the bundle, if the splice needs to be sized larger, it will automatically do that. So you don't have to keep track of that manually. Since we're just doing a demo here, I'm not going to build the entire harness, so let's skip ahead to the outputs of what you use when you're actually ready to construct the harness. The first relevant thing there is the bill of materials. And The bill of materials will have 3 tabs in it. It'll have the connector parts, then the devices, and then the wires themselves. So you can see here in the connector parts, it's got the quantity and part number of each connector in the project. It's got seals if the connectors have seals, and it's just missing the images of them, but the seals are here. The splices, the terminals, all the connector related parts are in the bill of materials here. And you can export this to a CSV so you can use it to easily order your parts. The devices are also listed here with quantities, part numbers, and so on. Again, you can export it to those as well. And then the wires are listed, how many feet of each wire, color, gauge, and type for the whole project here. And all those values get automatically updated if you come back and do any more design work. So there's nothing to like click to make sure they stay in sync. They're always in sync. We also have a cut list for the wires. So if you want to pre-cut your wire, this will tell you how many of each wire type length that you need. And again, you can export that as well. And the final tab are the build sheets. This is the sheets that show you how to build each constructor or each connector. They have the pinout, they have the part number, an image, then they have the pinout for each connector with the part number and image of the terminal that goes in the connector, and then the type of wire, the wire length is down here, and then what its destination is, where does it go, the connector label, the cavity number, and then what type of terminal is on the other end, as well as the circuit function. And if we come down here and look at something that has splices on it, like the sensor ground, we can open this tab here, or this expander, and we can see that this splice here, S5, fans out from the J1A 18 pin. It goes through the splice, and then on the other side of the splice it goes to the IAT pin 2 and the TPS pin 2. And any of the splices will have that. So if we look at the ones that have more of them down here, you can see the coil grounds do the same thing. And so when you're building this, you know exactly where that entire circuit goes. You can also print these if you would prefer to work off paper. And you can also go full screen if you're working off the screen and you want it to take up the whole screen. Well, that covers the basics. There's a lot more detail, but that will be coming out in other videos where I will drill down on each feature and get in much more detail. But for now, if you want to become a beta user and try it out and give me feedback, I would really appreciate it. You can head over to the website EfiWires.com and you can request early access there, and that'll send me an email to support@EfiWires.com. I'll give you the password that's required to get into the beta, and then you can log in, use it, and let me know how it works, and hopefully we can get this product going in the right direction so it'll be something that the community can really benefit from as a whole. Thanks for your time. I will talk to you later.